Hello everyone, welcome to SRIHAN Academy YouTube channel. In today's video, we'll discuss cells in parallel combination. This is very important question, 5 marks question from the chapter current electricity. So we'll see how they'll frame the question in final exams. Obtain expression for effective EMF and effective internal resistance when two different cells are connected in parallel. So what is parallel combination means? Cells are said to be connected in parallel when they are joined positive to positive and negative to negative, such that current is divided between the cells. Now you can see here diagram, the two cells of EMFs, consider two cells of EMFs E1 and E2 and internal resistance R1 and R2 are connected in parallel combination. Between the points here I'll take the B1 and B2. Okay, now here what is the total current in this combination means I1 current is passes through the cell EMF E1 and I2 current passes through the second cell of EMF E2. That means what is the total current in the circuit means I is equal to I1 plus I2. Now in the parallel combination, the potential drop across the each cell will be same. The potential terminal potential across the each cell will be same. Now here what is the potential difference across the first cell? Potential difference across first cell. So that is V is equal to E1 minus I1 R1. So from here we'll simplify this. I1 value will calculate. So I1 R1 is equal to E1 minus V. So I1 is equal to E1 minus V by R1. So this is the current passes through the cell 1. Now similarly I2 is equal to E2 minus V by R2. This is the current passing through the second cell of EMF E2. Now these two currents I'll substitute in the total current equation. So then I is equal to I1 means E1 minus V by R1 plus E2 minus V by R2. So I'll separate the terms here. So E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Now I'll write all EMF values in one side. So E1 by R1 plus E2 by R2 minus V is the common term, take out, then it is 1 by R1 plus 1 by R2. Now you take the LCM here. I is equal to, so E1 R2 plus E2 R1 by R1 into R2 minus V into R1 plus R2 by R1 into R2. Now actually I want the potential here. So this V value I'll send to the left side and I'll take the I is right side. So that means here V into R1 plus R2 by R1 into R2, that is equal to, so E1 R2 plus E2 R1 by R1 into R2 minus I. Now this value R1 plus R2 by R1 into R2 I'll send to the right side, then it comes to the denominator, then I'll directly write the reciprocal equation. So E1 R2 plus E2 R1 by R1 into R2 minus I. So into R1 R2 by R1 plus R2. So we have to multiply with this. So V is equal to E1 R2 plus E2 R1 by R1 into R2 into R1 R2 by R1 plus R2 minus I into R1 R2 by R1 plus R2. So now here these terms will get cancelled. So R1 R2 R1 R2 will get cancelled out. So continuation, V is equal to E1 R2 plus E2 R1 by R1 plus R2 minus I into R1 R2 by R1 plus R2. So this related to E effective minus I R effective. If I compare these two equations, so E effective is equal to E1 R2 plus E2 R1 by R1 plus R2. So and R effective internal resistance, it is R1 R2 by R1 plus R2. So in the question they mention very clearly, obtain the expression for effective EMF and effective internal resistance when two cells are connected in parallel. So this is the formulas. This is very important question, students. Be careful this each and everything. Some students they'll do the mistakes here, multiplication concepts. Be careful this simplification part. It is very important question for 5 marks. So if you are watching first time SRIHAN Academy YouTube channel, please subscribe and click on the bell icon. You will get all important 5 marks question and 3 marks questions and numericals as a notifications. Thank you all.